So today it's the big wiring all up today. So I've got the front off the box and I've got 2.5 meters of cable. So let's make a start on wiring things together. So first job is to remove some outer insulation of the piece of wire, like so. Keep that, might be useful. And the next job is to remove the earth wire from this length. Right, that's the first one in. From the RCD we've got the brown, black and grey for L1, L2 and L3. Going into the starter, brown, black and grey. Oh, got them all three there together. So that's the first connection made. Right, this is where things start getting technical. These sockets have a neon indicator on them, and that indicator requires a live 230 volt feed and a connection to neutral. So I've got one of those for each of the phases. I'm now connecting up bits at the back. So we've got the neutral connected into there, linked across to neutral on the next one, where there's a link across to the next one, and so on and so forth. Those loops, links, are individual pieces of wire. So if one pulls out, we'll lose the neutral to light the LED neon indicator. So anywhere there's a neutral failure, it will mean that the red indicator does not light on the 230 socket outlets. The earth I'm going to daisy chain the same, but it's not going to be a daisy chain. So the end of the earth wire is there. The next one is going to go into here, but I'm not linking the wire. I've stripped insulation from a section of wire. All I need to do now is bend that in half with one hand, which is quite clever, and I now have a loop to go into the terminal. So if this pulls out of this terminal, we'll lose the earth to the socket, but we won't lose the earth to anywhere else, because the earth wire will not be broken when the wire is pulled out. And there's the wire shoved in the terminal, and yet it's not broken. The wire is continuous. The terminal just needs tightening. And that's the 3 single phase sockets connected up, and I've inserted the individual cores back into some outer, just as an extra protection for those, because they're going to be flapping about when the panel's front piece is put back over into position. It'll mean there's a fair bit of flexing on those, and it just maybe keeps them a bit tidier. So there we have 3 3-phase outlets, sockets, and here we have one 3-phase plug, which is going to come from the generator. Now the unusual bit of wiring in here is the fact the neutral is linked to earth. Now, this is a recommendation globally that the earth and neutrals should be connected together. Normally this is done at the generator, but my generator, the neutral and earth is not connected, so that loop of blue is performing that function and making the earth and neutral the same voltage. It's a nice day and Bruce is coming out to play. So let's see how quickly I can get Bruce out. Right, that's Bruce out. So, where are we putting Bruce? As I want power in the garage, I'm going to hide Bruce behind the car. Like that. Come on. Just there. Come on, Spud. The cat investigates. Anyway, I have the key, so let's fire her up. Fuel pump's running. So it's a two-handed operation now. My left hand will operate the decompression lever and the right hand operate the key. Speed control set to tick over. Handbrake off. And here we go. Find decompression lever. Oh, there we are. And there we have it. Tick over. So what's next? Generator's over there, but I want power in the garage, so I need a wire. So the other end of my wire from the generator goes into that connector there in my breakout box, but it's not going in the garden. The box is going into the garage. And this is the garage. And this is where the box is going. Suspended under the shelf, one screw from above keeps it on the shelf. And this wire is a temporary arrangement. I'm just looking for somewhere to stash it. How about just in there? And next we have the final ingredient, the bulb that has appeared in another video. So there we have it. So now we can connect it up and see what works. Like that. Wrong way again. Right, let's get Bruce up to speed. And we'll press a green button. All being well, you can see the red lights. Yeah, you can see I've switched the left hand one off. Middle one, yeah, that's off. Right hand end one, that's off. So that's three phases. And see whether the red button puts them out. It does. So that was this red button here, stops it all. Power back on, red button still in, green button shouldn't make the lights light. They flashed, I saw them. We even get a flash out of the light bulb. More noticeable if I turn the lights off. Trip on, green button. It's like a photographer's flash. So that tripping has tested my safety circuits. So now we've got 3 phases. So these 3 neons prove we've got the phase L1, L2, L3 to these 3 single phase sockets, but these neon indicators are wired through these sockets, so it also proves that these sockets are properly connected with all 3 phases. And of course everything runs through the ammeters. So as this is the spot, I can zero my meters while I know there's absolutely nothing going through them. If I can. Oh, come on. Ah, magic. So that's the meters zeroed. Middle one was already zeroed. This needed a little tweak and that needed a bit more of a tweak. So power is on. Here's the connector for the lathe. That has gone in. Here's the connector for the milling machine. That has gone in, and nothing on the display. So now for something completely different. Having just plugged the milling machine in, there's a light on. So while we've got the light on, let's have a rotating spindle. While we've got a rotating spindle, can also have rotating traverse. That's the mill running light, 3.2 amps. And if I press the green button behind me, that's the lathe running light as well. So that seems all hunky-dory. So now let's see what happens with the milling machine's fast traverse, the one we have a problem with. Right, it's tripped the RCD. So that is more of a issue than I was expecting. Did we get three-phase consumption? That's a good question. If all three ammeters operated, and they did. Right, my first thought was I'd got a phase off on the mill, but it would appear I've got an earth fault on it, which is all rather a bugger. Anyway, that's a much better result than with the generator in its previous arrangement. Right, I've gone and fetched the electrifier into the place just to check out these sockets. So if I turn that one off, plug the fire in, turn it on, and we get 4.5 amps and 8.25 amps. Next one, 4.25, and finally the last one. I can get the plug in. So, good grief, it's tight. So those three sockets are working correctly, and there's no electrical fault on the fire. Well, there might have been, who knew? And so that completes the installation of the breakout box. Everything on there seems to be working. The lathe is working, and the mill's got an electrical problem, which I'm going to have a lot of difficulty finding, I think. So I need to clean up around the mill so I can get to it. Right, Bruce has run for an hour, so it's time for the shutdown procedure. So first of all, knock it down to a tick over and let it run for a few minutes, just ticking over before switching it off. That's pretty rough, isn't it?